Okay, let us go with the next 36th question. Which two requirements prevent the usage of AnyPoint MQ in company's network? Okay, so let us see. I have to select two. Ability of third party outside the company's network to consume events from the queue. Mm, Third party outside of company's network. Mm, See, I think if it is using AnyPoint MQ, we can configure a VPC to allow um, the incoming requests on a particular port or protocol. So even if we are using AnyPoint MQ, third parties outside of company's network can consume. So I don't think this is the one. Payloads must be encrypted. So AnyPoint MQ supports encrypted payloads. Single message payloads can be up to 15 MB. Okay, this I know. AnyPoint MQ supports message payloads up to 10 MB only. So if this is a requirement, then maybe you cannot use active MQ. Support for point to point messaging. Uh, this is also okay. Message broker must be hosted on premises. Okay, definitely this one. So it is on cloud, right? AnyPoint MQ is on cloud. So these are my choices. Okay, next. Question number 37. An organization has deployed runtime fabric on 8 node cluster with performance profile enabled. Okay. An API is using a non-persistent object store for maintaining some of its state data. What will be the impact to the state data if the server crashes? Okay, let me explain you the concept. So as you know, in runtime fabric, the let's assume that a runtime fabric is having multiple workers, for example, and suppose multiple nodes, node 1, node 2, node 3 in a Kubernetes. You know that RTF will be using Kubernetes, and suppose if I have deployed my application with 8 replicas, maybe the 8 replicas might be running like this. Now in RTF, if we are using object stores in a cluster, if you have multiple instances deployed as a cluster in RTF, the object store data will be replicated across the nodes in the cluster. Okay, by default replication will happen. Let me point you to the documentation. So object store feature, you can see uh, here is a document from help.mulesoft.com. It is a discussion about object store, whether it is supported in runtime fabric. Yes, Mule object store is supported in runtime fabric. However, CloudHub object store v1 and Cloud AnyPoint object store v2 are not supported. And also, file based persistence is not supported in RTF. So, object stores will never be saved to files. What it is saying, runtime fabric is a containerized deployment model where each application is contained within its own Mule runtime in its own Kubernetes pod. To facilitate containerization, the model is designed such that when application is deployed, updated, or restarted, the image is rebuilt and redeployed. Okay, this functionality means that object store, when used in runtime fabric, does not support file based persistence. This does not mean that file based object store cannot be used. It simply means that object store will not exist after any restart. The recommended usage of Mule object store in runtime fabric is in memory. And applications should have been designed to not have dependence on persistent object store data. And they say when runtime fabric is deployed in runtime fabric clustering enabled, the in-memory object stores are replicated to the nodes participating in the cluster, right? So Mule object store in memory is supported in runtime fabric cluster. So what this documentation says is object stores are replicated to nodes participating in a cluster. That's the default behavior. But in our question, they are saying an organization has deployed runtime fabric on a 8-node cluster with performance profile. Okay. Then I googled again in the documentation. Setting performance profile has two effects. It disables distributed queues using local queues instead to prevent data serialization or deserialization. It implements object stores without backup to avoid replication, right? In cluster mode, we will always distribute and share objects between the zones. So in performance profile, distributed queues are disabled. So as they are disabled in performance profile, if they have not given performance profile, I would say I would go with second option. Stale data is preserved as long as one node is unaffected by the crash. But they mentioned in the question performance profile. So distributed queues are disabled. So according to me, data is lost. Okay, next. Bank is using CloudHub runtime. Bank using CloudHub runtime plans requires that an email alert is sent to its internal operations team every time a applied policy applied to an API instance is deleted. Oh, whenever a policy is deleted, they want an email. How can these requirements be met? So let me explain you the concept. Um, so in API manager, through API manager, the API manager is running on the cloud, and through browser I can apply policy or delete policy. So whenever the policy is deleted through API manager, we want an email alert. So there is no alert that can be configured for this purpose. So what is the option? Any interaction in any point platform is written to audit logs. So whatever, suppose if you delete an API, delete a policy or add a policy or whatever, audit logs will contain the information. Now what I can do, audit logs has a REST API also. Now what I can do is I can write a flow where at regular intervals I query the REST API, audit logs REST API, and that contains any information about addition of policy or deletion of policy, etc. And in the flow I can actually write a logic to send an email. Okay, so here let us see the options. How can these requirements be met? Use audit logs in any point platform to detect a policy deletion and configure the audit logs alert feature to send an email. No, there is no such audit logs alert feature. No. Next, implement a new application that uses audit log REST API to detect the policy deletion and send an email to bank's operation team through SMTP connector. According to me, this is the option. And another one says create a custom connector to be triggered every time a policy is deleted in API manager, because it is not able to detect this type of action in CloudHub out of the box. The connector to be triggered every time. No. Even if you create a connector, that has to be again configured, right? I don't think this is okay. Any point monitoring to configure an alert to send. Now there is no feature that can send an alert in any point monitoring. No. So according to me, the second option is good. But again, creating a custom connector to be triggered every time a policy is deleted. Connector we can create, but a flow has to be configured with that connector, right? Mm. Because yeah, we can create a custom connector that can actually detect this type of action. But again, we could write it, but a flow has to be designed, right? A new application has to be designed using this connector. According to me, I will go with this option. Okay, so let's go to next question. A leading e-commerce giant will use Mulesoft APIs on RTF to process custom orders. Some customer sensitive information such as credit card information also is part of API payload. Which approach minimizes the risk of matching sensitive data to original and convert back to the original value whenever, wherever required? Actually, if you have seen my course, Mcia course on Udemy, you might know that there's a feature called as tokenization. So I would go with this option, create tokenization policy and apply tokenization policy to the API gateway. Okay. In RTF, we can configure this tokenization policy. Use both masking and tokenization. Why to mask? Not required, right? Anyway, when we are doing tokenization, not required to mask again. So create tokenization, I would go with this option. Okay, next. A company is migrating few on-premise applications from customer hosted runtimes to CloudHub. Okay. The applications are designed with configuration properties that are externalized to multiple YAML files and packaged within the same Mule application intended for on-premise environment. Okay, within the same jar, they have YAML files for different environments. Right? The applications are designed with configuration properties that are externalized and packed within same Mule applications intended for on-premise environment. To align with InfoSec groups requirements, all sensitive properties were encrypted before saving them within the YAML files. Okay, there are some secure properties also. Using the capabilities of AnyPoint platform, which approach must be used to migrate applications to CloudHub environments while simultaneously reducing application packaging efforts? Okay, so actually, what if the credentials are stored in YAML file? Whenever a credential change, again we have to repackage it, right? So better remove that encrypted properties from YAML files, because whenever such values are changed, we need to repackage them. So better to remove the encrypted packages properties from YAML files and deploy applications to CloudHub with encrypted properties using safely hidden properties feature. This looks to be good. Let us see the other options. Deploy applications without any change. No, this is not correct. Remove encrypted properties from YAML files and deploy applications to CloudHub with clear properties using CloudHub's safely hidden properties feature. Ah, why to have original values? Better to always encrypt. Even though you are using safely hidden properties, um, As InfoSec group wants all sensitive properties to be encrypted, we have to encrypt them. No, we will not go with clear properties. We should go with encrypted properties using CloudHub safely hiding properties feature. One more, remove the encrypted properties from YAML files. Add security properties in application descriptors. And deploy the applications to CloudHub using this properties feature. If you remove from YAML files, then no, this is not correct. You have to again configure them, right? In the applications descriptors, how to add secured properties in applications descriptor. No, this is not correct. I will go with first option. This is the most appropriate option. Okay. So let us see. Let us meet in the next video.